Hello, in this video, we will introduce recursive helper functions. So let's see why we need recursive helper functions. In the preceding video, we developed a recursive function for the palindrome problem. There's a problem in that solution is that when you call this function recursively, you create a string, a substring. So that's a new string, that's a new object. So please note that the string here in Python is immutable. You cannot change the contents of the string once the string is created, right? So every time you have a substring, that's a new string. What here we do here, how you save time by not creating a new string. So you can use this approach is we're going to introduce a helper function. So the original function is the same as palindrome. So, but we're going to invoke this help function here. This is the string s, but this is the beginning index indicating the range of the string, and this is the end of the index. So now we're going to have this s low and high. So if high is less than or equal to low, that means you have to check everything. So it is true, it is the palindrome. Else if the first one is not equal to the second one, so that means this is not a palindrome. Else, we're going to reduce the problem. Return is palindrome help. This is the helper function. And the same is s, but the low is +1 and high is -1. So that is, the range is reduced, excluding the both ends, the first one, the last one. And this is the test. Helper functions are very useful. When you design your program, write your recursive function, if you cannot call this function directly, so you can introduce a helper function and use that function, that's the recursive function. Let's look at this selection sort example. This is the, in chapter 7, we have introduced selection sort. Is to find the smallest element in the list and swap it with the first element. So we do it repeatedly in the remaining list. We can write it naturally using recursion is this. So here we are going to sort the entire list. And now, but we are going to use the help sort help. So this help is, this is the list, but this list has the location, low and high. So initially, when you invoke the sort help, this is the list. The low is 0 and higher is this -1. So, but what is this -1 here? Length of the list. Now, in this sort helper, we find the smallest element and swap with the first element. And this is the, now we're going to sort the remaining one is sort helper, and now as LST and low is now increased by 1. And this high is still unchanged. So this is to use the helper function here for solving the selection sort recursively. So here's another example for the binary search. We're going to rewrite this binary search using recursion. So the same thing here. We have this list, and so we compare the key with the element in the middle. of the list. So please note that for the binary search to work, all the elements in the list is already pre-sorted. So we compare this key with the element in the middle. And so if key is less than the element in the middle, so we now recursively do performing the binary search in the first half. So what we're going to do is now we are going to use this range here. This is the list and this is the key. This is the low and high. So initially, and low is 0 and high is length, len, and LST and -1. So this is recursive binary search helper. If low is greater than high, so you have searched everything, you did not find it. So in this case, you return a negative number. So we are going to return negative low, negative -1. So this low is the insertion point. So we want to have that information built into this return value. So this negative value indicating not found further, where to insert it. So for this mid, if key is less than the mid element, so we're going to return recursive binary search help. So this is recursive binary search help. So this is the one, and with the list, but the low is the same, and the high is mid -1. If key matches the middle element, you can return the index. So this is the return the index. And for this, the last one, so it's in the key is greater than the middle element. So now the second half, so you have to write this, invoke this recursive binary search helper for this list using the key. And now this is the second part is mid +1, and this is high. So that is all for this section using recursive helper functions. See you on the next video.